In Precalculus Lesson 11, we will be solving polynomial inequalities, beginning with finding graphical solutions. This is section 2.6 in the college algebra textbook, and let's begin by solving x squared plus x minus 12 is greater than or equal to 0. So the first thing I'm going to do is give that x squared plus x minus 12 on the left side of the inequality the name f of x. So I have f of x equals x squared plus x minus 12. And then what I'm going to be trying to find is where f of x is greater than or equal to 0. So if I graph y equals f of x, which you've had some practice graphing quadratic functions, it will look like so. You can see the graph of y equals f of x has x-intercepts of -4 and 3. So if we're looking for where f of x is greater than or equal to 0, we're looking for where our y values are either greater than 0 or where our y values are equal to 0. That occurs when my graph is either above the x-axis or on the x-axis. So if you look at this shaded area here, we can see that f of x is greater than or equal to 0 from -infinity to -4, including -4, union from 3, including 3, to infinity. So this would be the solution. Now let's look at solving x squared is less than x. We'll solve this a little bit differently. We will give a name to each side of this inequality. The left side I will refer to as f of x. So I have f of x equals x squared. The right side I will refer to as g of x. So I have g of x equals x. What we're trying to find then is where f of x is less than g of x. I will graph both f of x and g of x together. So we have the purple graph here is y equals f of x. The green graph is y equals g of x. If I look for where f of x is strictly less than g of x, I'm looking for where the graph of f of x is below the graph of g of x, not where they meet. That would be where they would be equal. So my solution here then, if you can see, would be from 0 to 1, not including those endpoints. If, on the other hand, we had f of x is less than or equal to g of x, we would want to put square brackets here to include 0 and 1. Let's look at solving this inequality a little bit differently, and this is the general method we would use. We would subtract x from both sides to get a 0 on the right side. So I now have x squared minus x is less than 0. On the left-hand side, x squared minus x, I'm going to refer to x squared minus x as h of x, and now I want to graph the function h of x here. So I have the graph of y equals h of x. Well, what am I trying to find? I'm trying to find where h of x is less than 0. That means where my graph is, that means where y is less than 0. If you think of it that way, it's where my graph is strictly below the x-axis, as you can see right here, and that occurs from 0 to 1. Notice that we have the exact same solution we had by the other method we used for solving x squared is less than x. Let's look then at solving a polynomial inequality. 2x times x plus 1 times x minus 3 is greater than or equal to 0. So the left side of this inequality I will refer to as f of x, and then if I graph f of x, I have the graph right here. We've just finished working on graphing polynomial functions, so you should be able to do this on your own. It's good practice if you want to try it. And f of x has x-intercepts of -1, 0, and 3. Well, I should say our graph intersects the x-axis at -1, 0, and 3. The intercepts would be -1, 0, 0, 0, and 3, 0. So what we're looking for is where f of x, my graph here, is greater than or equal to 0. That means where my graph is either above the x-axis or is on the x-axis, which I'm shaded in right here. And we can see that occurs from -1 to 0, union from 3 to infinity. And again, because with the inequality we include this equals sign, we're going to have square brackets here, including the endpoints. Try on your own. Number 1 for this lesson is to solve the inequality by graphing 3x cubed minus 12x is less than or equal to 0.